Hi, Paul here from Easy Composites. This video is going to purely focus on the subject of getting a perfect seal on a vacuum bag. Now, I do realise that this probably isn't the most glamorous topic to be covering, but this is the video that I wished existed when I started out in the industry, as I do understand how time-consuming and frustrating getting that perfect seal can be. So in the video, I'm going to be looking at all of the reasons why you might get a leak in a bag, how to check the quality of the seal or the integrity of the seal on a vacuum bag, and then finally, how to identify and fix any leaks that may be present. So, what are the main causes of leaks in vacuum bags? Well, it will come down to one of 5 reasons. Firstly, you might have a leak in the bag before you even begin, or you may have done an improper job of making up the perimeter seal using the sealant tape. It is also possible to get leaks that occur during the vacuum bagging process and handling the materials at that stage, and sometimes you will even get bags that will burst or puncture during the cure. And then finally, it is always possible that a drop in pressure will be caused by a leak somewhere else in your vacuum system. So let's address that first point then, having a leak in your film before you even start. So firstly, I will say it is vitally important that you do use high quality materials that are specifically designed for vacuum bagging. We'll be using the VB160 in all of our demonstrations, and this is suitable for the vast majority of composite processes. It's by far and away our most popular film, and it has become an industry standard. And I will say that in the thousands of meters of these materials that I've processed, I can't think of a single time when an imperfection in the film has been the cause of a leak on a bag. It's far more likely, if you have a leak in your film at this stage, that it will have been caused by the way that you've stored the material. So ideally, it should be stored on a dedicated material storage rack where it's going to be safe from getting knocked or banged. But if you don't have this, it would also be fine to wrap these materials up when not in use and store them safely on a shelf. One thing I absolutely wouldn't do though is leave these kicking around in the corner of your workshop or on your bench where they are very likely to get knocked. That's likely to cause a puncture, and that's likely to cause you a lot of frustration further down the line. So assuming we have a film that has been stored safely and we know has perfect vacuum integrity, we're now going to look at the next and probably most likely cause of a leak, and that is in the perimeter seal itself. So I'll be doing some demonstrations now on best practice on how to seal both an envelope bag and a tool face sealed one. Of the 2 types of bags, the first that I'm going to demonstrate is an envelope bag. Now an envelope bag is just that. It's an envelope that you place your moulding inside, you draw the air out, and the film comes in from both sides. And it's this type of bag that you're going to be using for any prepreg or wet layups. Now, there are some instances where you might choose the method that we'll demonstrate later, tool face sealing, but that wouldn't be until your moulds become very large or particularly awkward for this process. So I'll be doing the demonstration using this small prepreg moulding, and I've pre-cut my film here and I've made it slightly larger than the part, and that's to allow the film to follow all of the contours in this moulding without having to stretch or put strain on the seal. Now, this is quite a shallow part, so the bag that I've got here isn't that much larger than the moulding. But if you do have something with deep draft or particularly complicated shapes, it might use a lot more bag than you would expect. And so you do need to think about this before you cut your film, just to make sure that you're going to have enough for your project. Now this piece of film is actually one piece folded over. And so what I'm going to be doing is creating a U-shaped seal, then folding the bag back over to create that envelope. It would also be perfectly fine if for whatever reason you need to run 4 faces of seal, and actually all of the methods and techniques are just the same. If you're making a fold over bag like this, it's important to ensure that the tape goes past the point where the fold is. This ensures that the seal will extend fully around the fold. If possible, the film should be tensioned while you're applying the tape so that it doesn't have any creases. A good method of doing this is to use the roll itself and slide this over the film to hold tension as you drop the tape down. Corners can be approached with 2 different methods. You can either tear the backing paper and bend the tape around the corner in one piece, or cut the tape and overlap the next leg. Both ways will seal equally well, but for speed, I generally use the first method. The film can then be folded over and sealed, leaving one face open. I'm sealing these sides without the mould inside the bag, as it's quicker and easier to make the seals up neatly while the film is sitting on a flat surface. A common mistake for beginners is to peel off long runs of the backing paper. This makes holding tension more difficult, and so I would generally only peel back around 300 or 400 millimeters at a time, and then hold a light tension on the film before lowering it down onto the tape. Our mould can then be placed into the bag and the through bag connector attached. Although you can use the fitting itself to cut a hole in the film, I suggest pinching the film and then snipping it. It's okay if the hole created is a little smaller than the fitting, as it will stretch out of the way, but it must be smaller than the inner raised rib on the connector's base, as this is the part that forms the seal. When you tighten the connector, check that the film is not creasing. Sometimes you may need to tension the bag a little to stop this happening. The connector can then be fully tightened, but it does only need to be moderately hand tight. With the fitting in place, the final side can now be sealed. Once closed, the seal should be pressed firmly to ensure that it's making good contact with the film. The fastest way I find to do this is to use a pinch and stretch method. This will help to uncrease any slight folds that you may have in the film. So I'm going to do this around the whole seal, even in the areas that look good. And I'm applying extra pressure in any corners and any joins on the tape, as these are more likely to leak. The vacuum pump is connected and the air drawn out. Throughout this drawdown, the bag is manipulated so that it conforms with all of the contours. One device that can be quite useful to have at this stage is a leak flow indicator, and these will spin if there's any air flowing through them, indicating that you've got a reasonably substantial leak somewhere in your bag. So if this is spinning, you can continue round your seal, checking it until you see that it stops. Now, what they won't do is indicate if you've got only a very, very slight leak. For that, we'll still need to do a drop test, and we're going to be looking at that a little bit later. So this is a properly made up and sealed envelope bag. And if you're experienced, making a bag like this is going to take 2 or 3 minutes, and 99% of the time it's going to be perfectly sealed right from the off. But if you're new to these materials, there are a few challenges that you might face when making up that seal that I didn't demonstrate there. So what I'm going to do now is repeat the exact same bag, but this time intentionally introduce some of those challenges and show you how to best overcome them. So here I'm getting everything wrong. I'm falling short of the fold line, not holding the bag flat, so I'm introducing creases and generally doing a very poor job. When you're applying the tape, you might find that you are running offline. This isn't a problem. Simply sharply pull the tape back to where you are happy, tear the backing tape and adjust its course. If you find that you're unable to keep the film flat when applying the tape, there's a good likelihood that you'll have a few creases and wrinkles in the film. This won't be a problem as long as they're not too large, so like these ones, they can be left and worked out later. In this area where the tape is short, it's better to simply extend it with an extra piece of tape rather than folding the bag in a different place, which would put us out of line. So this is a common issue. The bag is starting to wander off the seal. If this happens, a short, sharp pull on the film will allow you to get back to a good area, and then the film can be steered by twisting it slightly on top of the sealant tape. If you're doing this, try to make the turn gradually over a few centimetres, and this will cause shallower ripples in the film. Now that we've come to the corner, I can see here that we've come short of the tape. But this is easily remedied by simply introducing a pleat into the seal, which effectively shortens that side. The bag has now been closed off, but there are many places where we've got creases in the film. Carefully inspect these, and any that you find should be stretched out. This is done by pulling on the film until they flatten and then press down on top of them to ensure that they've made good contact with the tape underneath. You can see here where the overlap is misaligned that there is a slight air path into the bag. Again, a firm press on this will make full contact with the sealant tape. We're now going to look at how to make an effective job of a tool seal bag. Now these are different from envelope bags in that we're going to seal the film directly onto the perimeter of the mould, essentially making the mould the other side of the bag. Now you're going to use this method if you're doing a resin infusion. Envelope bagging doesn't really work for resin infusion because it will draw a vacuum over the back of the mould. That will pull resin under the back of the mould, which will not only make a mess of it, but will also affect your resin ratios and calculations. So I've already got my infusion stack all set up here, and this is where I have already broken one of my rules. And generally, I would advise putting your tape around the perimeter of the mould before you do the layup, because it's quite easy to get stray fibres, like you can see here from the peel ply. And if you were to put the tape over the top of those, it's going to compromise the seal. So the first thing that I'm going to do now for this demonstration is just make sure that this area is completely clean and clear of any stray fibres. When running the seal onto the mould flange, you will need to include pleats. Pleats are there to provide the extra bag that's needed to follow all of the mould contours. If you're looking for more information on this, and also how to set up the resin infusion as a whole, I'll put a link in the description to some of our other videos that cover this in much more detail. When you're making pleats, there are two approaches. You can make them like this, from one continuous piece of tape folded over. Alternatively, you can attach them to the seal once it's already been applied. To do this, you'll need to tear and peel back some of the backing tape, and then fold another piece with some feet on and attach it onto the main seal. Both approaches work fine. The first method is faster, but you will probably find that the second method is easier if you are new to this. Here I'm following the seal with the film to allow me to estimate the amount of additional bag required by the pleats. The key to success with this type of bagging is to ensure that the bag is centered and remains square during the closing. When you approach pleats, it's easiest to lay them flat, peel the backing from one side, apply the film, then fold them over flat to the other side and continue. It's very easy when you're following the edge of a mould to unintentionally start turning the bag, particularly on these pleats. So do periodically check your bag is running square and aligned with your mould. Another thing to watch for when doing this is that a fibre doesn't drop onto the seal. Carefully check for this before peeling the backing off, and also only seal a short section at a time. The tops of the pleats are one of the most common places to get leaks, so do pay attention here and ensure that the film is making good contact with the tape right over that top section. Slightly folding the seal at the top can also make this easier in some cases. Once you get round to the very last stretch before you close the bag off, do check to see whether your bag is too long or too short. It's highly unlikely that you will have judged everything perfectly and have it just following the contour of that last pleat. So if your bag's too short, this would be sort of pulling down tightly like that. You could just fold that pleat over and make it a slightly smaller pleat. Or, like we have here, is we've got slightly too much, so we're going to need to extend that pleat by probably 20 or 30 millimeters. Now, in some cases, you might find that you need to extend this by a few hundred millimeters. It's not a problem. As long as it's done neatly, it will still seal perfectly well. Once it's all closed up, the seal should be pressed and worked all the way around the perimeter. The pliability that you have in the tape will allow any small creases in the film to be stretched and worked out. The pleats, they're the most likely place to have a leak, so these do require a bit more attention. Firmly pressing the base in one direction and then the other will help to close any gap under the tape. Now that the bag's fully sealed, we can go on and make our resin feed line and vacuum connections. So to do that, I suggest putting a slight chamfer onto the end of your pipe because it makes installing it a bit easier. And then on your fitting, all you need to do is a perforation into the center of the fitting. And then your pipe will press firmly into that. And then what you want to do is just stretch the bag to try and get rid of any creases that are around that pipe, because that will mean that the seal will be that much better with the sealant tape. Then just taking a small amount of sealant tape, we can just pull that nice and tight. We can just wrap that around. You only need 1 or 2 laps. I've seen a lot of people will use far too much sealant tape at this stage. And although it will seal fine like that, it can be quite difficult to find a leak in that area if there is one. Okay, so we've now looked at how to properly create the perimeter seal, but this alone won't guarantee that your bag is going to be airtight if you've got a leak elsewhere in the film. And it is quite possible to cause punctures or leaks in the main area of the film while you're handling it and doing the vacuum bagging. So we're now going to look at best handling practice and how to avoid those accidental punctures. On this subject, the first thing we're going to talk about is the working environment. It's really important to make sure you've got no sharp edges or objects in your working area. So the edges of your benches should be checked for sharp corners, and any tools or equipment that you don't need should be taken out of the area. You do also need to make sure it's clean of any stray fibres or any dusts that might compromise the seal. And then I would say, if you're envelope bagging, the next thing you should be doing is working on top of a padded surface. If you don't do this, it's very easy to cause a pinch puncture on your bag between the hard worktop and the hard mould surface. And if you get a leak on the back of the bag, these ones can be particularly difficult to find. So I'm just using a piece of EVA foam. This is the sort of thing you would get in a yoga mat or a camping mat. And this does make a really good temporary work surface. But if you've got the luxury of setting up a dedicated vacuum bagging area, then I would suggest not only padding the top, but also padding the sides as well. And all of this is just going to help to reduce the risk of catching the film on an edge. Now, in a professional composites workshop, the most common way that you'll see these padded tables made up is just by taking several layers of breather fabric, placing this over the table, and then stretching and securing some film over the top of that. I think probably the reason you see it done this way so often is that it does make a good work surface, and of course those materials are always readily on hand. Now, it's not just your workspace that can cause punctures. Your molds themselves can be a problem. It's important to check over, particularly around all the trim lines, that there's no sharp edges, make sure they're deburred. And if you've got wet laid molds, it's quite common to find that you've got little splinters of glass on the back that will act like needles to your vacuum bagging film. So check that over and sand them out if any are found. So we've got our workspace is properly set up, our molds have been checked over. The next most likely way that you're going to get a leak is by the way that you physically manipulate the film into the mold. Now, you will have seen in many of our previous videos that whether you're doing a prepreg, resin infusion or wet layup, it's often necessary to press the material down into any corners and contours. Now, when you're doing this, you're going to be using a blunt tool. It's obviously important that it's blunt, and you're going to be pressing down firmly into the corners. Now, it's important that you do only press or roll the tool. If you drag it, that will quite quickly sort of tear into the film and is likely to cause a leak. But along with that, you can further reduce the risk of getting a puncture by wrapping some breather over the top and just softening the tool off further. Now, when you're doing this, sometimes you might slip, or there might be an area that you think you've pressed too hard and you might have caused a leak. If you get to that stage, stop, take out a marker pen and mark up the area that you think you've caught. And that way, if you find that you've got a leak when you do a drop test, you can quickly identify those areas that you suspected you could have punctured, go back to them and check them over. Okay, so we've looked at how to properly make up the seal and how to avoid getting leaks or punctures in the main areas of the film. But it is also possible that leaks can occur while you're holding the vacuum down or during the cure itself. And the way that this nearly always happens is if the bag is having to excessively stretch over a feature or is bridging too much in a corner. Now, the most likely place that this is going to happen is going to be on the back of the mold, where you won't have been paying as much attention or might not have been paying as much attention during the bagging process. So I've got an example here of the sort of mold that's likely to cause you a problem. First thing you'll see, it's a multi-part mold, so we have fasteners. If you do have fasteners, it's really important to make sure that you cut the studs off flush with the nuts and deburr them, make sure there's no sharp edges there. I'm even using some nylock nuts here because they have a slightly softer edge. Normal nuts would also be fine, but probably the best solution would be to use a dome nut, and that's going to completely cover the end of the stud. But this alone, I would not recommend just bagging with one layer of breather. I would put an extra 2 or 3 layers over the top of every fastener, and that's just going to help to further smooth out and soften those features. Without that, if you left a stud long and just use one layer of breather, it's really likely that when the bag pulls down that it's going to have to excessively stretch, and these are going to cause a puncture. Another feature that we've got on this mold that can cause a problem is that we have a negative shape here. It's a concave because of these flanges. And if we weren't paying attention during the bagging process and getting the film into all of these contours, it would be really easy to forget about it and leave a bridge section of film. And as the vacuum's being held, that's going to be stretching the bag down into that corner, which ultimately could stretch it too far and again cause a puncture. That's basically everything that you need to know to stand the best chance of having a properly sealed vacuum bag. But just having a perfect seal on the bag itself isn't going to help if air is being introduced from elsewhere in your vacuum system. So let's now just quickly touch on some of those areas that are likely to cause you problems. Firstly, any threaded connections, they will need to be sealed properly, and this is throughout your entire system. So here we've got our quick release coupling connecting onto our through bag connector. We've got a threaded connection between the two. This needs sealing either with PTFE sealant tape or a suitable thread sealing compound. Now, on the subject of the quick release couplings, these themselves can leak. So before you use them, do just quickly visually inspect and just checking that those O-rings inside are not damaged. This particular one is damaged. You can see we've got a slight nick here. And so that's going to need replacing before we use the connector, as otherwise it's likely to allow a small amount of air to pass through. Now, another fitting that you're going to see very often in a vacuum system are hose tails. Now, these are generally very reliable. As long as you're using the right size for the hose that you've got, they very rarely leak. But they can do if you do one of the most common mistakes that I've seen, and that is to slice a knife down the side of the hose in order to make removing it easier. Now, if you do this, there's a really high likelihood that you're going to put a deep scratch right down the barb, and that will create an air path that when you connect up the next hose could again potentially leak. When it comes to tool sealed bags, of course, the mould itself will also need to be airtight. Now, a good consistent gel coat mould will be airtight unless it's damaged. Now, there could be obvious damage like chips or big chunks taken out of the mould. Obviously, those are going to need fixing. But the most common way that I see these leaks are small hairline cracks around the flange. And the reason for these is when demoulding a previous part, maybe a wedge has been driven in too hard, then that will stress the flange, and that's just put a slight crack in the gel. Now, that slight crack basically closes back up, so it's quite difficult to spot, but it will be an air path straight under your seal. So it is really important before you begin to carefully inspect for these hairline cracks, and if you do find any, repair them. Leaks can also come from elsewhere in your wider vacuum system. So that could be on your catch pot, any hoses and connections, any valves, or even on the pump itself. So all of this should be periodically inspected to ensure that it's all in good condition and everything is properly sealed. With that said though, it's still important to isolate your bag from all of these downstream components when you're performing a drop test, as otherwise any slight leak on this would indicate as a leak on your bag, so you might end up hunting around for a leak on the bag that doesn't actually exist. Now, if you do have a fractional leak on your equipment, I wouldn't be too concerned about that. It's unlikely to affect your overall vacuum level, and because it is downstream of the process, it's not going to have a significant impact on the part itself. Obviously, any major leaks that you see here, they should be addressed. So let's now move on and have a look at the drop test. The purpose of a drop test is simply to check whether the bag is completely sealed. And the way that we do that is by disconnecting the vacuum and then connecting on a gauge and watching it over a period of time to see if it drops. If it does drop, that's indicating that we've got a leak somewhere in the bag that's going to need to be fixed. Now, you can set your own sort of thresholds or tolerances for what you would say is acceptable, so you can adjust the time or the vacuum level, but typically for prepreg and resin infusion parts, on a mechanical gauge like this, you're looking for no noticeable drop over the period of about half an hour. Now, for an envelope bag, the easiest way to connect these is just onto the same fitting using a quick release coupling. In the case of an infusion, you would just put hose tail barb and press that onto your resin feed line and do the exact same test. While it is preferable to have your gauge directly connected to the bag like this, when you're doing an infusion, it's also possible to use the gauge that's on the catch pot itself. Now, if you're doing this, you will still need to clamp between your vacuum bag and the catch pot, as otherwise any leak that's on your catch pot or elsewhere in your system can track back and give you false readings. So with that clamped off, after the allotted time has passed, if you come back and find that you have had a slight drop on your gauge, that's indicating that there is a leak somewhere in your system. Now, if this is only very slight, it's not necessarily a problem. All you need to do in this situation is pull full vacuum back onto the catch pot, then close down your vacuum pump, and then unclamp the line between the catch pot and the part. If at this point you see that the gauge drops, that's indicating that the leak is in your bag and not elsewhere in your wider system. Now, if you're doing a lot of vacuum bagging, it might be worth considering investing in a digital gauge like this vac checker. These have much higher resolution than you would get from a mechanical gauge, and that means that you can have the exact same accuracy of test conducted over about a minute rather than half an hour. Now, we have actually done a product spotlight on this on our products channel, so do go and check that out if you're interested in finding out more. So after the time has elapsed, in a perfect world, you're going to come back and you will find that this gauge has not dropped. And that'll be indicating that you've got a properly sealed bag and you can get on with your process, whether you're curing a prepreg or running a resin infusion. But what happens if it's shown a leak? Well, let's now look at how you would best deal with that. The first thing I would do in this situation is go round and check the seals. These are by far and away the most likely place that you're going to have a leak. So in the case of an envelope bag, I would just go around sort of pinching and stretching out that seal all the way around the perimeter, and also just inspecting it to make sure that there are no creases. On a tool sealed bag, much the same. I'll go around that perimeter, I'll pay particular attention around the pleats, and also be checking that there are no stray fibres under the seal. Another thing I would do at this stage is plug up any areas that I suspected I might have damaged. So we've got this area here that we marked out with marker pen, and all we need to do is just stretch out any wrinkles from underneath it and then press a piece of sealant tape firmly in place to plug it up. Having done this, I would then repeat the drop test. And most of the time, just by going around that seal and addressing any areas that you thought you might have punctured, you will find that your bag will be completely sealed. But if the second drop test also shows that you still have a leak, this is the point where you're going to need to track down its exact source. Now, the simplest way to do this is to get yourself into a quiet area of the workshop, pull full vacuum, then switch off your pump so it's not making any noise, and simply listen for the slight hiss that might be coming from it. If you do hear that, track down where it's coming from and repair the area. Now, if it's on the seal, that's probably just going to be a case of pressing down or stretching out a crease. If it's in the main area of the bag, then we're just going to plug it up with some tape like I showed you earlier. Now, there are some tools that can help you to track down leaks, the simplest one being a stethoscope with a piece of tube attached. The way to use this is to take the end of the tube here and just run it round, listening out for the leak. Now, the way that I would approach this is to start out by going around the seal first, as this is the most likely place to have a leak. And then if nothing's found there, I would then just systematically work along the bag, listening for that slight hiss noise that would come from one. Another piece of equipment that can prove quite useful is an ultrasonic leak detector. Now, you use these in much the same way as you do a stethoscope, but these are listening out for the high frequency ultrasonic noise that's very often generated by an air leak. Whilst they can help you to track down leaks more quickly, they can also be quite expensive. So I wouldn't say that they're a necessary piece of equipment, particularly if you're just starting out. So if you've checked the bag over and you haven't been able to easily find the source of the leak, this is probably the point where you might want to consider cutting your losses and rebagging the project. I've fallen foul of spending far too long trying to track down a leak, and the more time you invest hunting that leak down, the more invested you feel in the bag, the less inclined you are to replace it. But honestly, you're better off setting yourself a time limit. For me, I always say that I won't look for a leak for any longer than it took me to bag the project in the first place. After this point, it's much better to just rebag the project, as statistically, your next bag is much more likely to be sealed. One last thing that I'm going to touch on is don't be tempted to continue on with your process if you know that there is a leak in your bag. Now, in the case of a resin infusion, any leak whatsoever will cause a problem with your part. But with processes where your pump is running throughout the cure, like prepregs and wet layups, you might get away with a very slight leak, but you are definitely running the risk of compromising the part. And also, most vacuum pumps don't like to be run against a leak. It actually drives the oil through them, which can ultimately damage them. So if you know you've got a leak, do fix it before you proceed. So that really covers all of the advice that I could think of that I felt would have been useful to me when I was starting out. And I hope that for many of you guys, it will be useful too. Now, I'm sure there are many things that I have missed out of this video, but I do know that we've got a lot of composite professionals that watch our channel. And so if any of you guys have got some advice for people starting out, please post it in the comments section below. As ever, I'd like to send a huge thank you to all of our customers and subscribers for your support, and we'll see you in the next one. Of course, all of the equipment and materials that you've seen used in this video can be ordered online from the Easy Composites website. If you're based in the EU, you can now order directly from our Netherlands warehouse on easycomposites.eu, and for the UK and the rest of the world, please visit easycomposites.co.uk.